Okay, we're at lesson 1.7. We just completed solving equations, and we had three different methods for solving equations. We used the graphing method, substitution, elimination, and today we're going to be solving inequalities by the graphing method. And so let's just jump into some examples, very much like we did with graphing the solution to a system of equations. I'm going to start with this blue inequality, and I'm going to treat it as though it reads as y equals 3x minus 5, because for inequalities, I need something known as the boundary line. And the boundary line is the equation form of this inequality. And so this is a review of sketching a linear equation. I start at -5 on the y-axis. And then I count a slope of +3, so I'm going to go up 3 and right 1. Maybe do that one more time. Okay, so I got the points that the boundary line will go through, and at this point I'm going to look at the inequality, because since it does not say or equal to, I need to do a dashed line. So you'll just grab your straight edge, and we're going to do a dashed or a dotted boundary line. Okay. So you line those points up, and there's my boundary line for this blue inequality. And the way I go about this, you may follow a different procedure, and that's fine. I'm going to wait and do my overall shading at the end. I'm going to go ahead and draw both boundary lines, and then I'm going to do the shading. If you want to shade as you go, that's okay. Greater than, remember, refers to above the line. So if I was shading right now, I would be shading this upper part of the boundary. All right, so let's go ahead and do the boundary line. Think of this as y equals 4, so that we can sketch the boundary line. Well, remember, line equations that start with y equals, and they just equal a number, that's got to be a horizontal line. It's going to cross that axis at that number. And the only way to accomplish that is to draw a horizontal line straight across, crossing y at 4. And before I draw the boundary line, I want to pay attention to what the inequality says. It says or equal to, so I need to be careful and change my line to solid. So this is the boundary line for y equals 4. Yeah, pretty close, I guess. It's hard to line this up exactly. And now I'm going to do the shading. So we already said that for the blue, we would be shading above the line, because it says greater than. So that's this area. And then for the red, it's shading less than means below the line. Okay? So that's the underneath side. So what I'm interested in when I'm solving a system of inequalities is, where do these two shadings come together? So this first time around, I'll just show you blue like this. I don't typically do this, but just for overemphasis. All right, if I'm doing the blue only, I'm shading everything above the blue line. And then, if I'm doing the red only, I'm shading everything below. Less than means below the line. So my overall answer is where the blue and the red meet. So everything in this area where blue and red come together represents the solution. So what we're saying here is, any ordered pair that I could come up with that falls in this blue and red meshed together area is a solution to this system. So if you're one of these that likes to shade as you go, I'm okay with that. So maybe you shade red and then you shaded blue. I just need to make sure, don't make me guess what your overall final solution is. If you've got shading everywhere, it should be especially dark where the two shadings come together. So if you're one of those, and that's fine, just make sure there's no doubt about what your solution area is. Yeah? As far as I'm concerned, that's all you have to shade. And that's what I would do. But some people like to go ahead and shade as they go. And that's okay too, as long as, don't make me guess. Okay, which one is the real solution? Does that make sense? All right, any questions on this first example? Any questions? Yeah, I'm okay if you want to use color. I probably won't do it on a test, but if it helps for homework, that's fine. Okay, letter B, same process. I'm going to take the blue inequality and I'm going to get it in slope-intercept form so I can see what the boundary line looks like. All right, so we did some of this yesterday. I'm going to add 2x to both sides. And then I'm going to divide by 3 on both sides. And I'm ready now to sketch the boundary line, which would be the equals version of this. Y equals 2/3 x minus 8. And so I'll go down to -8 on the y-axis. And then I look at the slope. It's 2/3 positive, so up 2, right 3. And since it says or equal to, this is going to be a solid boundary line. All right, so there's the boundary line for the blue inequality. And since it says less than, I'm just going to go ahead and keep in mind that I will eventually be shading below this blue line. Less than is below the line. But I'm just going to hold off and do my shading at the end. All right, now let's look at the red. The boundary line would be y equals 2/3 x minus 1. So there's my y-intercept. Also a slope of 2/3, so that should have given you a clue about what these two boundary lines will do. Two lines that have the same slope are called parallel. Okay, as long as they have different y-intercepts, and these do. So we have parallel lines. Are they ever going to cross? No. And I'm going to have a solid again. All right, so there's the boundary line for the red inequality. So now I'm going to do the shading. Blue says less than. And less than is below the line. Red says greater than. And greater than means above the line. Well, I'm interested in where these two shadings collide. Do they mesh together? They do not. And so when this happens, I need to finish off my answer and interpret this as no solution. If the two shadings do not come together, then I don't have a solution to this system. All right, any questions so far? Okay, let's try this one. I'm going to do the red boundary line. It's already in slope-intercept form, so it starts at -3. And I have a slope of +2, up to right 1. It's going to be a dotted boundary line, so I need to change. And there's the boundary line for the red inequality. And in just a minute when I start to shade, I'll be shading below. Less than means below the line. And when we had this previously, the boundary line y equals 4 is horizontal. So I'm going to draw a horizontal line crossing the y-axis at 4. Hello? Sure. Okay. Don't get old. All right, so we're going to draw this boundary line for y equals 4, and it's going to be a solid horizontal line. And now we're going to do the shading. So the red is less than, which is below the line. The blue is greater than, which is above the line. And so where we put those two shadings together, we're talking about this area. Less than the red, greater than the blue is everything in this region. So any ordered pair that we could find that would fall in this yellow shaded area represents a solution to the system. All right, any questions about letter C example? And I think I just have a couple more here. Same idea here. We're going to draw the red boundary line first. And it has a y-intercept of 3. And a slope of positive 1. And it's going to be solid. And now the blue, to get the boundary line, we need to solve it for y first. So I'm just going to divide by 2 or multiply by 1/2. Same result. And so now I'm ready to sketch the boundary line, which is negative 2.5 is the y-intercept. And the slope is positive 1/2. So up 1, right 2. And it's also going to be solid. And this is a case where I really needed to lengthen this red line, so I'm going to go ahead and do that. You sometimes need to make those lines a little bit longer to give them a chance, if they're going to cross, give them a chance to cross. And now we'll do the shading. So it's above the red, but below the blue. Above the red and below the blue, that's just this, well, as far as what I have graphed, it's a small area. It's going to continue to widen. But from what I have shown, it's this area right here, and it will just continue on in that area forever and ever. All right, any questions about letter D? And then I've got one example that involves the graph of an absolute value, V. We had one of these on our last test. And then combine that with a regular line, and then we'll do the shading. So just a reminder, when you do these graphs of absolute value functions, we want to find the vertex first. And I gave you a little formula to help you find the vertex. So I'll label the parts of this absolute value inequality. The number in front of x is called m in our formula. The other number inside the absolute value, either added or subtracted, we'll label as b, and then the number outside the absolute value is always c. So you put it all together, and it helps us find the vertex of this v, which makes it really pretty easy to graph. And the vertex is going to be -3, -4. So that's like a starting point. All right, so I'm going to plot -3, -4. And from there, I'm going to look at the slope number, and I'm going to count out a positive 3 slope and a negative 3 slope. And when I put those together, it makes the V. My V is going to be solid because it says or equal to. And the shading greater than is above the line, so in just a minute when I shade, I'll be shading inside the V. It's greater than both lines, everything inside. And now I just have to do the boundary line for the blue, the linear equation. So let's solve it for y first. And now it's ready to graph the boundary line. I have a y-intercept of 7 and a slope of negative 1/2. Down 1 right 2, up 1 left 2. Also a solid boundary line. And now I'm going to put the shadings together. So we said that greater than for the V means inside when the V opens up. It's everything inside the V. But less than the blue. So below the blue while still inside the V. Everything, every ordered pair that you could come up with in this region that's shaded yellow represents a solution. All right, and that's all the notes. Hopefully that gives you enough examples to be able to complete the homework successfully. If you do have any questions, though, just let me know.